Data analysis is an important step in research. Without analyzing the data, we can't find the result. Statistical method used in data analysis depends on the nature of the data. Chi-square test is a non-parametric test and which is used to find the association between two categorical variables, and it is also used to find the distribution of the one categorical variable. I am Dr. Jaising, and in this tutorial is made for understanding the concept of the chi-square test and also how can we use this test in social science research.
Please like, share and subscribe to JS Academy and click the bell icon to get the latest videos at the earliest. A nonparametric chi-square test for data analysis in social science research.
Our topic is a non-parametric chi-square test. Types, formula, examples, and calculation in Excel. What is the primary goals of today's lecture? Today, we will explain and the learner will understand to understand the concept of chi-square test, to be familiar with the different types of the chi-square test, to be able to frame hypothesis for testing it using the chi-square test, to be skilled in testing hypothesis manually using the chi-square test, and to be skilled in testing hypothesis using the chi-square test in Excel software. These are the goals. Now there is the basic question. As we know that people vaccinated against COVID-19 disease in different continents of the world. If the problem is are they equally distributed, then chi-square test can give the answer to this problem. What is chi-square test? A Pearson's chi-square test is a non-parametric statistical test used in the case of categorical data. The most important thing is that if the data nature is categorical type, means it is on nominal or ordinal scale, then chi-square test should be used. And this test is used to determine whether the distribution of data is significantly different from what is expected. Chi-square test is often written as chi-square and is pronounced chi-square, rhymes with the I-square. It is also called chi-squared. Now we will show you the details of the chi-square test. Pearson's chi-square test, often referred to simply as the chi-square test, are among the most common non-parametric tests. Non-parametric tests are used for data that do not follow the assumptions of the parametric test, especially the assumptions of a normal distribution. It means that if our data is not normally distributed, then we should use this chi-square test. For testing a hypothesis about the distribution of the categorical variable, we need to use a chi-square test or another non-parametric test. Categorical variable can be nominal or ordinal and represent the groupings such as localities, professions, species, or nationalities. If the nature of the data is categorical type, then we should use the chi-square test because they can only have a few specific values. Such type of the data have only the specific values and they do not have the normal distribution. But if in two variables, one is the categorical type and another is not of categorical type, it is normally distributed and continuous variable, then we should not use the chi-square test. We should use another parametric test like ANOVA or any other test. What is the use of the chi-square test? Chi-square test is used to test the hypothesis about the distribution of the observation in different categories. That is, to test the hypothesis about the distribution of the categorical data. It means by using this test, we check the hypothesis about the distribution of the data, and the nature of the data should be categorical type. To see whether the distribution of the categorical data for one independent variable is similar or different to that expected distribution. That is, to compare the observed distribution of the categories to a theoretical expected distribution. Pearson's chi-square test is used to test whether the observed frequency distribution of a categorical variable is significantly different from its expected frequency distribution. We can see here that there are two types of the frequencies. One is the observed frequencies, which which we get from the data, and one is the expected frequency, which we expect that such type of the distribution should be. But chi-square test tells us, is there difference between the observed frequency and expected frequency or not? These two type of the frequencies are significantly different or not. If such type of the question is there, then we should use the chi-square test. In chi-square test, we check the hypothesis like observed frequencies and expected frequencies do not significantly differ. If such type of the null hypothesis is there, then we use the chi-square test. The observed frequencies are the same as the expected frequencies except for chance variation. And if the observed and expected frequencies are same, then value of the chi-square will be 0. If the frequencies we observe are different from the expected frequencies, then the value of chi-square goes up. The larger the values of chi-square, the more likely it is that the distribution are significantly different. Hence, on the value of the chi-square, we can get the decision about its significance or not. Means the observed frequency and expected frequencies are significantly different or not. But to check it, we should make the contingency table. There is the need to make the contingency table, and contingency table is similar to the frequency distribution. But in frequency distribution, if there is two categorical data, then we make the contingency table. Frequency distribution describe how the observations are distributed between the different groups, and frequency distribution are often displaying using frequency distribution table. A frequency distribution table shows the number of observation in each group. But when there are two categorical variable, a specific type of the frequency distribution table we make is called the contingency table, and it is used to show the number of observation in each combination of the group. We can see in table, here is the two categories are male and female of the gender category, and education category is graduate and postgraduate. And in this table, frequencies 24, 35, 15 and 9 in the corresponding cells are given. So such type of the table is called the contingency table. In calculating the value of the chi-square test, we make the contingency table. After this, we find the value of the chi-square test. Now we will discuss when to use a chi-square test, in which condition we should use. There are some assumptions, and first, before using the chi-square test, we should use the assumptions. If they are fulfilled, then only the chi-square test should be used. What are the assumptions of this chi-square test? A Pearson's chi-square test may be an appropriate option for testing the data if all the following conditions are true. First is, investigator wants to test a hypothesis about one or more categorical variable. If one or more of the variables is quantitative, a different statistical test should be used. Alternatively, the quantitative variable could be converted into the categorical variable by separating the observations into intervals. It means there is option that we can change it, the variable, quantitative type variable, into a categorical variable. Then we can use the chi-square test. Otherwise, we should use parametric test like ANOVA or any others. The sample was randomly selected from the population, and third assumption is there are a minimum of 5 observations expected in each group or combination of the groups. Now, there are basically 3 types of the chi-square test. One is the chi-square test of association. It is called the chi-square test of association between two variables. And second is called the goodness of fit test. And third is in simpler frequency data categories, categorical data. In this condition, we can also use the chi-square test. But we will discuss in this lecture only 2 types. One is the chi-square test, goodness of fit test, and second is chi-square test of independence. Chi-square goodness of fit test and chi-square test of independence, mathematically both tests are same, but most of the time we think that they are different because they are used for the different purpose. We use it for the different purpose, so we think that they are different. But same uh, thing is here, that we find the difference between the expected frequency and observed frequency in both the cases. Now, what is the goodness of fit test? We will talk about the goodness of fit test. If our problem is that we want to see whether the distribution of categorical data for one independent variable is similar or different to the expected distribution, that is, our aim is to compare the observed distribution of the categories to a theoretical expected distribution, testing the divergence of observed result from those expected on the hypothesis of equal probability, or to test the divergence of observed results from those expected on the hypothesis of normal distribution. In, in these cases, there are 2 types of the distribution. One is according to the normal or equal probability, and we say that this is expected, and another frequency that we obtained in the data collection, that is the observed frequency. And to check there is difference between the observed frequency and expected frequency, we use the chi-square test, goodness of fit test. But the main thing is that in the goodness of fit test, only one variable is considered. There may be different categories of the variable, but only one variable is included in the study. A chi-square test or goodness of fit test can be used to test whether these observed frequency are significantly different from what was expected, such as equal frequency. Means we expect that equal frequency distribution will be there, but we obtain some frequency and we will check whether it is different from the equal frequency distribution or not. Suppose the students having musical interest are equally distributed in different grades at the preparatory stage. Our example is this. In this example, some students have musical interests and they are equally distributed in different grades at the preparatory stage. We want to check are they equally distributed or not. In the table, we can see that number of the students 15 who have the musical interest are in grade 3, and in grade 4 18, and similarly in grade 5 there are 10 students. So we want to check whether they are equally distributed or not. Now we want to discuss about the hypothesis and alternative hypothesis in goodness of fit test. How we should make the hypothesis in the goodness of fit test. As we know that it gives the answer to the whether the frequency distribution of the categorical variable is significantly different from the expectations. Often but not always, the expectation is that the categorical categories will have equal proportion. For example, is hypothesis for the chi-square goodness of fit test, expectation of equal proportion. Means two condition may be possible. In one condition, our expectation may be of equal proportion. Means all the data are equally distributed as we expect it. And in other case, we expect that equal proportion is not there, some other type of the proportion may be there. It may be according to the normal probability curve or according to some other criteria. Now in this case, when we expect that equal proportion is there, then the format of null hypothesis will be the student of 12th standard studying in different educational board appear in IIT exams in equal proportion. Here we want to check is the distribution of the 12th standard students who are coming from the different boards like UP board, CBSE board, ICSE board, and they appear in the IIT exams, are they equally in equal proportion? So to find the answer of this question, we make this null hypothesis, and the alternative hypothesis will be the student of different boards of the 12th standards appear in IIT exams in different proportions. So goodness of fit test for the expectations of different proportions. In this category, we will explain in the case of as we expect that the data is distributed in different proportion. The format of the null hypothesis will be this is null hypothesis made in an hypothetical example. The tourists from different European countries visit India in the same proportion as the average over the past 5 years. Here we are not saying that in the equal proportion, but we are saying that five past 5 year average and the tourists from different European countries who comes in India, they are distributed according to the average. And the alternative hypothesis will be the tourists from European countries visit India in different proportion from the average over the past 5 years. Here the word we use is different proportion, and in null hypothesis we use same proportion. Chi-square test of independence. This is the second type of the chi-square test, use of the chi-square test. And in this test, as we have discussed, that in goodness of fit test, there is only one categorical variable. But in the test of independence, there will be two categorical variable. The chi-square test of independence is used when there are two categorical variable. It is used to test whether the two variables are dependent or related to each other. And our basic problem is if we want to find the answer of the question that are these two variables are dependent or related to each other, then chi-square test we should use. If the two variables are independent, unrelated, the probability of belonging to a certain group of one variable is not affected by the other variable. It means if this is independent, then one group may not affect the second another group. Chi-square test of independence in hypothetical example, the null hypothesis format will be the proportion of people doing professional job like liking Democrat is the same for doctors, lawyers, and teachers. In this hypothesis, the two variables are used. One is the professional job And in professional job, three jobs are considered: doctors, lawyers, and teachers. And their interest are liking towards the political parties, and political parties also have some category like Democrat, Socialist, Republican. So in null hypothesis, we want to check that the proportion of people doing professional job liking Democrat is same for doctors, lawyers, and teachers. And if we make the alternative hypothesis, then this will be the proportion of people who are liking Democrat differs with respect to the professional job. It means they are different for the doctors, lawyers, and teachers. They differ in their liking towards the Democrat. And similarly, we can make this hypothesis for the Socialist and Republican parties. The table is given here. Liking towards political parties, the professional job, in this table we can see Democrat, Republican, and Socialist are three parties, and the profession is doctor, teacher, and lawyers. And we want to find their distribution is same or not. So we can also see that the example in this case is professional job and liking towards political parties are independent. In this discussion, we can see that the chi-square test, a test of independence, is used to test whether these observed frequencies are significantly different from the frequencies expected if the professional job is unrelated to the political parties. So we can see that the chi-square test for independence, in this we can also check the variables are likely to be associated or not associated. Means if two variables, whether they are associated or not, we should use to find the answer of this problem chi-square test. Null hypothesis, the type of the movie and whether or not people bought snakes are unrelated. This is an example of this type in which we use two variables. Type of the movie is one variable, and people bought snakes or not, this is the another variable. So movie genres like drama, comedy, action, fantasy, horror, romance, western, and thriller is different categories of the first variable, that is movie types. And the second variable is whether or not the patrons of those genres bought snakes at the theater. The owner of the movie theater wants to estimate how many snakes to buy. So in this case, chi-square test of independence will be used. Another example is there. People are being vaccinated against COVID-19 disease in different states in India. States differ having their GDP average. Uh, Three categories of the GDP of the different states in India are considered here, that is average, low, and high. And number of the people vaccinated and GDP of the states associated. Is the number of the people vaccinated and GDP of the states associated? This is the problem. So in this example, we can also use the test of independence. In another example, a veterinary clinic has list of the dog breeds they see as patients. The second variable, whether owners feed dry food, canned food, or a mixture. Is the dog breed and types of food unrelated? If our problem is that dog breeds and types of food are related or not related. So in this case, chi-square test of independence will be used. In, if the frequency distribution is simpler form and data is categorical in nature, then chi-square test is also used. Sometimes data will be a lot simpler, consisting only of frequency data. In these cases, participants do not contribute scores for analysis. Instead, they each contribute to a head count within the different grouping categories. This kind of data is known as categorical data, and examples of which could be gender, like male and female, if such type of the data is available. And this type of the data is in simpler form, like male and female only, or university degree of classification, graduate, postgraduate, PhD, also like pass and fail, or any other variable where each participant falls into one category. When the data we want to analyze is like this, chi-square test is appropriate test, and in this condition we can also use the chi-square test in simpler frequency form. Now we want to show you the formula for the chi-square test. Pearson chi-square test use this formula chi-square. It is denoted as the Greek symbol chi-square is equal to sum of O minus E square divided by E. Here chi-square is the chi-square test statistics, and summation symbol is there to sum this, and O is the observed frequency and E is the expected frequency. It means for each cells we have to find the difference of observed frequency and expected frequency, and then square this and sum for all cells, and after after dividing it by expected frequency, we take the auto sum of all these, and we find the chi-square value. The larger the difference between observation and expectations gives the bigger the value of chi-square. If the difference is larger, means observed frequency, it is different from the expected frequency in the cells, then chi-square value will be bigger. And to decide whether the difference is big enough to be statistically significant, the chi-square value is compared to the critical value, and critical value can be found from the table given for the chi-square. Now at the last, we want to discuss about how to report a chi-square test in APA style. Most of the time we do not follow these rules, but we should follow in when we do our dissertation or thesis, then we should write in appropriate form as the APA style. First thing we should care about, no need to provide a reference or formula since the chi-square test is commonly used statistics. So for the chi-square test formula, statistics should not be references, and refer to the chi-square using in Greek symbol. This type of the symbol should be used. Although the symbol looks very similar to an X from the Latin alphabet, it is actually a different symbol. Greek symbol should not be italicized. Include a space on either side of the equal sign. If chi-square is less than 0, then we should use 0 in the starting, that is leading 0 before the decimal, since the chi-square can be greater than 0. Provide two significant digits after the decimal points. Report a chi-square alongside its degree of freedom, sample size, and p-value in this format. Means degree of freedom, sample size, and p-value should be mentioned. like this format: chi-square in bracket degree of freedom comma capital N, that is equal to sample size. We should mention the degree of the value of the degree of freedom and also the size of the sample, and is equal to chi-square value should be written, which we find by calculation, and after comma value of p, that is the critical value, should be mentioned here.